Lesson 18.2, I'm going to do some extra examples on completing the square, just so you can make sure you understand the process. All right, so it says complete the square to form a perfect square trinomial. Then write each trinomial in factored form. So there's two things we're going to do here. All right, so the first one says x squared minus 12x, and then we want to complete the square. So what goes in this blank to make it a perfect square trinomial? So remember, we have to do half of b and then square it. So if we take half of b and square it, negative 12 divided by 2 is negative 6. Negative 6 squared is 36. All right, so factored form for number 6 would be x minus 6 squared. So that would be factored form. All right, let's look at number 8 because it also has a coefficient of 1. So we're going to take the middle term, half it, and square it. So if we half 10, it's 5. 5 squared is 25. All right, so down here, I'm going to write factored form. So it's going to be x plus 5 quantity squared. All right, so number 10. Number 10, if I take the middle term and I half it, so I'm going to have negative 1 divided by 2, and then negative 1/2 squared would be plus 1 squared is 1, and 2 squared is 4. So that's going to be plus 1/4, and factored form is going to be x minus 1/2 quantity squared. All right, now look at the ones with a coefficient of, or a coefficient in front of your x squared, which means you have an a greater than 1. So we have to change this formula just a bit. This is b squared divided by 4. 2 squared is 4, so b squared over 4. And in order to do the ones that have an a, you have to do b squared over 4 times a. So we have to add the a in this part of the formula. So b squared, b in this case is 10. 10 squared is 100. 100 divided by 4 times 25. 4 times 25 is 100. So 100 divided by 100 is 1. All right, so let's write that in factored form. So it'd be 5x plus 1 quantity squared. All right, number 7, 4x squared plus 20x. So I'm going to do 20 squared. 20 squared is 400. 400 divided by 16. Let's see. So let's do 400 divided by 16 is 25. So when I complete the square, this number is going to be 25. And then I want to write that in factored form. So to write this in factored form is going to be 2x plus 5 quantity squared. All right, and one more. All right, so I'm going to have plus some number here. So I know my factored form is already going to be 3x minus something, because there is a minus in the middle. And now I have to figure out what goes in. Don't know why I'm writing all over that. All right, so to find this number again, I'm going to do b squared over 4a. b squared, okay, negative 8 squared is 64. 64 over 9 times 4 is 36. All right, so what's 64 divided by 36? All right, it gives me a decimal. Let's see if we can just put that as a reduced fraction. So that is 16 over 9, which is very nice because 16 is a perfect square and 9 is a perfect square. So the square root of that would just be 4/3 is what goes in my factored form. So this number squared equals that. So 3x minus 4/3 quantity squared is the factored form of that one, number 11. All right. Solve each equation by completing the square. When necessary, give answers in simplest radical form. All right, simplest radical form. All right, so we're not going to give decimals. We're going to leave it in radical form. All right, so let's look at a couple examples here. Let's look at number 13. So it says x squared plus 4x equals 5. So to complete the square, we're going to move the equal sign over a bit. And leave room to complete the square. Because we're going to have a perfect square trinomial. We have to have another term here. So equals 5 plus blank. So I'm going to add something here to keep this equal. Remember, we have to be very careful to make sure these are equivalent. So if I add something here, I have to add it to this side as well. So what do I add here? I'm trying to make this a perfect square trinomial. So I'm going to take the middle term. I'm going to half it and square it. Take 4, half it, 2, square it, 4. Add 4 to both sides. It's still equivalent. All right, write the left side in factored form. X plus 2 squared. 5 plus 4 is 9. How nice. That's a perfect square. I'm going to take the square root of both sides. So I'm going to have a plus or minus square root of 9. So I'm going to have x plus 2 equals plus or minus the square root of 9. Square root of 9 is 3. So I'm going to have x plus 2 equals 3. And x plus 2 equals negative 3. Having that plus minus means you have both positive and negative 3. All right, subtract 2. X equals 3 minus 2 or 1. Subtract 2. X equals negative 5. All right, plug it in and check it. So 1 squared is 1 plus 4 times 1. 4 times 1 is 4. 4 plus 1 is 5. So that one checks. Very easy to check it. You always know if you did it correctly if you just plug it in and check it. Negative 5 squared is 25. 25 times 4 times negative 5 is negative 20. So 25 minus 20 is 5. So that one also checks out. All right, let's look at one more here. All right, let's look at number 16 since it's written a little bit differently. So we're going to have x squared plus 8x minus 5 equals 0. So the first thing I'm going to do is move the 5 out of the way. So I'm going to put blank because I am going to complete the square. But let's add 5 to the other side. 5 plus 0 is just 5. But now if I add something to the left, I have to add it to the right as well. So what do we add? Half it and square it. So take 8, half it is 4, square it is 16. Here I'm going to write this in factored form. So it's going to be x plus 4 quantity squared. 5 plus 16 is 21. Take the square root of both sides. So I'm going to have x plus 4 equals plus or minus the square root of 21. 21 is 7 times 3. It's not a perfect square, so there's no point in breaking it down. All I have to do is get x by itself. So I've got to subtract 4. X equals negative 4 plus or minus square root of 21. All right, that one's a little bit harder to plug in and check it, but this is simplest radical form. So we are going to leave your answer in this form, okay? And I have checked it, that is correct, but we're going to move on so we can do one more example that's a little bit more challenging, but just to make sure you have plenty of examples to make sure you know what you're doing here. All right, so let's look at number 30. 6x minus 4 equals negative 5x squared. All right, we don't need a negative x squared, so let's go ahead. First, let's put it in standard form. So I'm going to add 5x to both sides. 5x squared plus 6x minus 4 equals 0 now, since I moved that to the other side. All right, so I'm going to have 5x squared plus 6x equals I'm going to add the 4 over here to get it out of the way. And then I have to have either divide this whole thing by 5 or multiply it by 5 to make this a perfect square so that we can complete the square. Most people like to not have fractions, so I'm going to do it this way for you guys. So 5 times 5 is 25x squared. 5 times 6 is 30x. Then we're going to have plus blank equals 20 plus blank. All right, so what did I do? I made the first term a perfect square. Now I have to complete the square by doing b squared over 4a. All right, so let's see what that is. All right, so b squared, so I'm going to have 30 squared divided by 4 times 25 is 100, and that is 9. All right, so I'm going to add 9. All right, so this in factored form is going to be 5x plus 3 squared, and that equals 29. Now I can take the square root of both sides. 5x plus 3 equals plus or minus the square root of 29. This is not a perfect square, so just leave it and then solve for x. So subtract 3. 5x equals negative 3 plus or minus the square root of 29. You can't combine these, so you're just going to leave them separate just like it is. I'm going to divide everything by 5. X equals negative 3 plus or minus the square root of 29 over 5. All right, so this says simplest radical form, not an approximate, so you don't want to have a decimal unless it says, you know, you can round it to so many decimal places. This is simplest radical form, so this would be where you stop. Now, if these could be reduced, we would do that, or if this was an irrational number, we would want to rationalize the denominator, but in this case, this is the final step. So that is number 30, and that is one of the more complicated ones that you will see. All right, so I hope these examples helped. If you have any questions, let me know.